Okay, good afternoon, grade 11s. Today we will be doing functions. Now, functions is just another word for graphs. Functions is just another word for graphs. Okay, now I'm going to do revision of the grade 10 functions that you did last year with everything that you are supposed to know so that we can, tomorrow and Thursday afternoon, we can do grade 11 functions. So the first one was the parabola. And what you did last year was the equation y equals ax squared plus q. Now, can you remember that the a tells you if the parabola is smiley or sad? Now, if a is positive, it's a smiley parabola. And if a is negative, then it's a sad parabola. So the a gives you the shape of the parabola. Then the q, now for grade 10, the q was the turning point as well as the y-intercept. The turning point and the y-intercept was the same point. I will do an example just now. And of course, the x and the y, that's almost the most important thing. X and y means all the coordinates for all the points on the parabola. So the coordinates of any point on that parabola. Now, if I can, we're going to do an example just now. What must you do when you sketch a parabola? There's a few steps that you're going to do. The first one is the shape. So you're first going to determine the shape. So the shape tells you it's smiley if A is positive or it's sad if A is negative. Then you find the intercepts with the axis. So for y-intercept, you make x0. And for x-intercepts, there's usually 2. You make y0 and you factorize. Okay, now for grade 10 graphs, the turning point and the y-intercept is the same point. So tomorrow you will see we will add another step where we calculate the turning point. Now what can they ask you? They can ask you for the symmetry axis, for the domain, for the range. Now, if I can draw a parabola, can you see that if this is y equals ax squared plus q, then this parabola is symmetrical in the y-axis. So for all the parabolas that's symmetrical in the y-axis, the y-axis is also the symmetry axis. And the y-axis has an equation, x equals 0. You know that by now. And your x-intercepts had the same values but different signs. And then can you see there, the turning point was the same as the y-intercept. Now, if they ask you domain or range, I want to explain domain and range in an easy way because sometimes I know that you struggle with that. So if I give you, say I give you an oval with x-intercept, say, -4 and 4, and y-intercepts -1 and 1. And I ask you for the domain. Now, if you can remember, because sometimes you get confused, domain and range. Domain stands for the x values and range for the y values. Now, I always remember it like this. D for domain comes before R for range in the alphabet, and X comes before Y in the alphabet. Domain comes before range, like X comes before Y. So domain means X values and range means Y values. Now, if you want to know the domain or the range, you know you want the values from the smallest to the largest. Now, if I want the domain, that means I want the X values. Come from the left-hand side with your bicycle again. Okay. If you, the first place, the very first place where you will hit that graph is at -4. So the smallest value is -4. Now you carry on, you go with your bicycle. The last place where you will exit the graph is there at +4. So that's your domain. Now all that you must decide now are the brackets round or square. Now a round bracket means an excluded point, and a block bracket means included. So that point is not excluded. There's not an open dot there. So it's a block bracket. There's not an open dot there. So it's included. And then if they ask you for range, now you know range means Y values. And the smallest Y values are here at the negative infinity side. So now you come with your bicycle and you drive upwards. Where's the first place where you will hit the graph? At -1. So that's your smallest Y value. And where's the last place where you will exit that graph? There's the last Y value that you will touch. So that's 1. But now again, there's not open dots there. Those dots there are included. So therefore, it's a block bracket and a block bracket. So if you can remember this and you can understand this, then it's easy to find the domain and the range of any function. So if I ask you the domain and the range of the parabola, now you are supposed to make brackets, arrows on the ends of all your graphs, because they did not give you restrictions. So unless they give you restrictions, there's always arrows there. Now a parabola goes out, out forever. Okay, out forever. So if you come with your bicycle, where's the first place where you will hit the graph? From the left-hand side. Well, the graph is everywhere. So the smallest value is -infinity. And the graph is going on forever. So you will never exit that graph. So it will carry on to infinity again. Now this you can also write as x element of all the real numbers. So you only write one of the two, x element of -infinity to infinity or x element of r. It's the same. You understand, it's the same. If I ask you the range, okay, now I can't move the range. So if I ask you the range, you know the range is the y values. Now you come with your bicycle from the -infinity side. Where's the first place where you hit the graph? It's at the turning point's y value, that point there. So it's the y value of the turning point. And where will you exit the graph? Well, never, because now it goes on to infinity again. So it's from the y value of the turning point to infinity. Now that point there is not excluded. That's why you're going to put a block bracket there. But remember, you cannot tell me where's infinity. So here you also see infinity always have a round bracket because you cannot tell me where's infinity. Now, if I have an upside down, a sad parabola, and there's my turning point, what will be the range for that parabola? Can you see there's arrows on the ends? So now the smallest y value is negative infinity. And what's the last place where you will exit the graph? At the y value of the turning point. So it's the y value of the turning point again, and that is included. So for a parabola, the range is either from the turning point to infinity or from minus infinity to the turning point's y value. Okay, now let's do an example. Draw y equals 3x squared minus 27. Show the intercepts with the axis. Give the domain and the range as well as the equation of the symmetry axis. Now, if we have to draw, we said the first thing is the shape. Now, there's an A that is 3. That's a positive value. So the shape will be smiley. To get the y-intercept, we make x equal to 0. Now, it doesn't matter if you have a parabola, a straight line, a exponential graph. If you want y-intercept, you make x 0. So, if I make x 0, I get y equals 3 times 0 squared minus 27. That will give me minus 27. Now, I want the x-intercepts. And for x-intercepts, you make y 0. And I say again, doesn't matter if it's a parabola, a straight line, exponential graph, hyperbola. If you want x-intercept, you make y 0. So now I make y 0. And I said we factorize. Now, can you see that you can divide the 3 away? So that gives you x squared minus 9. And I can factorize that by saying x minus 3, x plus 3, because it's difference of two squares. So x equals 3 or x equals negative 3. Now that's all that I need for now. So I can plot. My y-intercept is negative 27. X-intercepts 3 and negative 3. And I draw my parabola. There's my parabola. Okay. They ask for the domain and the range as well as the equation of the symmetry axis. Now, can you remember the symmetry axis? You know what symmetry means. If I stand in front of you, then we all have a more or less, okay, people, we're not 100% symmetric, but I have a symmetry axis, a vertical line through my nose. So here's the symmetry axis, because the left side of the parabola can fold over onto the right side if I fold in this y-axis. So the symmetry axis is the line x equals 0, or the y-axis. But remember, if they ask an equation, then there's the equation. An equation has an equal sign. And then they also ask the domain and the range. So domain, range, you know now that domain means x values and the range means y values. So domain, can you see these arrows at the ends? The parabola is going out forever. So again, we say from minus infinity to positive infinity. Or if you don't want to write it like that, you can write x element of all the real numbers. Remember, if you use the infinity, minus infinity to positive infinity, you must remember to use round brackets. Otherwise, you're going to lose a mark. And then the range, where's the smallest y value? I come from minus infinity. There's the smallest y value. It's at negative 27. There's not an open dot there, so that point is included. That's why it's a block bracket. And then it goes to positive infinity. Infinity with a round bracket again. Okay, are you satisfied? Now, obviously, if we have a negative there in front of the 3, the parabola will just be upside down. In other words, a sad parabola. Okay, now let's go to the hyperbola. Now, the hyperbola that you did last year had an equation y equals a over x plus q. Now, the a gives me the shape again. Now, I'm going to do that thoroughly, because if you have that incorrect, then everything is incorrect. Say I have y equals positive 3 over x, and I have y equals minus 3 over x, because that's where the difference come in. If there's a positive, your hyperbola is in the first and the third quadrants. So that's the shape. If your hyperbola has a negative there, then it is in the second and the fourth quadrants. So depending on the value of this a, you will have your hyperbola in the first and the third quadrant, or in the second and the fourth quadrant if you have a negative there. Now, it's important to understand and to keep in mind that those two parts are two halves of one hyperbola. It's not two hyperbolas that I've drawn here. It's two halves of one hyperbola. And these are the two halves of one hyperbola. Now, I want you to see, they can ask you, is the hyperbola increasing or decreasing? Now, I want you to think of the bicycle again. If I come with my bicycle. Oh, that's a terrible bicycle today. Can you see, if you come from the left-hand side and you hit the graph, what's going to happen? You are going down. If you come with your bicycle and you get there and you hit the hyperbola, you are going down. So can you see that both halves of the same hyperbola is decreasing? So this is a decreasing hyperbola. You're going down all the time. So if it's a positive a, you have a decreasing hyperbola. And if you come with your bicycle here and you hit the graph, you are going up. Make it green. You're going up, because you must keep on moving to the right-hand side. If you come from the left-hand side and you hit the graph, you are going up, because you must keep going in the positive direction. So can you see that this is an increasing graph? So if your a value is negative, your hyperbola is increasing. If your a value is positive, your hyperbola is decreasing. Okay, now what's the meaning of the q? This q gives you the asymptote. So that means that if there's a plus, the graph moved up. So up if there's a plus q, and down if there's a minus q. And which asymptote is it? It's the horizontal asymptote. Now, if we go back, I call these two, I call the mother graphs. The mother graphs before I move them, okay? Now, can you see that the y-axis is an asymptote and the x-axis is also an asymptote? The y-axis is an asymptote and the x-axis is an asymptote. What does asymptote mean? Your graph never passes that line. It wants to go to that line as close as possible. And you see, it goes to the x-axis, but it never touches the x-axis. It goes to the x-axis, but it never touches the x-axis. The same with the y-axis. So the x-axis as well as the y-axis, both cases are asymptotes. So I have asymptotes here of x equals 0 and y equals 0, the x and the y axis. But now if I add a q, it means I move the graph up or down. So now I will have a new asymptote. We will do an example just now. And then important again, this x and this y stands for the coordinates of any point on that graph. So that's what the x and the y stand for. Doesn't matter if you have a parabola, hyperbola, exponential graph, doesn't matter. It means the same. So let's do an example. Draw y equals 2 over x minus 4. So first thing is the shape. Because there's a positive 2, and you see a equals 2, therefore your shape will be in the first and the third quadrants. In other words, the decreasing one. But now here is your Q. So that means you have an asymptote, a new asymptote. So you always have two asymptotes for a hyperbola. Now, if you just add the minus 4, it means your graph moved down with 4 units. So this whole graph moved down with 4 units. So my x-axis will not be an asymptote anymore. The asymptote will move to the line y equals minus 4. Okay, but now that means that that half there will also move 4 units down. And this half here will also move 4 units down. Because remember, the asymptotes are part of the graph. So if the graph moves, the asymptotes also move. It's like I cannot take you outside a room but leave your arm inside the room. You understand? You're one whole person. Everything moves if you move. So the whole graph moves. Now, can you see that in this case, I'm going to have an x-intercept? Can you see there will be no y-intercept? The graph doesn't cut the y-axis because the y-axis is still an asymptote. So the asymptotes now will be the line x equals y equals minus 4. So the horizontal asymptote will be y equals negative 4, and the vertical asymptote will still be the line x equals 0, or the y-axis. But now, because it moved down, I have an x-intercept, so that means I must calculate. So the asymptotes, the shape, the asymptotes, and now there's an x-intercept. So how do I get x-intercept for any graph? I make y equal to 0. So my equation, I take my equation, 2 over x minus 4, but I make the y equal to 0. Okay, and I just solve. So that gives me 2 over x equals 4. Take the 4 to the other side. and make the 4 a fraction, because if you're busy with fractions, it's easier if you make everything fractions. So make the 4 a fraction by putting it over 1 so that you can cross multiply. 4 times x is 4x equals 2. So that means x equals 2 over 4, which is a half. And now if I draw, you always start drawing with your asymptotes. So start drawing your asymptotes. And you said the asymptotes is y equals minus 4. And remember, an asymptote is a dotted line, and the other one is x equals 0. That's the y-axis. So there's your other asymptote. There's your y-axis, and there's your x-axis. Now we said the shape is in the first and the third quadrant, so it's that one. So it's going to be there and there. And I've calculated the x-intercept, which is a half. So there's my hyperbola. Give the intercepts with the axis, I did that. Asymptotes, I did that. Now the domain and the range. Now remember what we said about domain and range. So domain means x values and range means y values. Now can you see, if you come with your bicycle, domain means x values. If you come from the left hand side, can you see that this graph comes from minus infinity and it carries on to positive infinity? So the domain will again be x element of all the real numbers. But now you must not forget, and I love asking the domain and the range of the hyperbola because you forget this but. You can never include an asymptote in a domain or a range because it means that the graph does not exist there. So you cannot include an asymptote because the graph is not there. And what's the asymptote that has something to do with the x's? This one. You said it there, x equals 0. So that asymptote you must remember to exclude. So domain is x element of R, but x not equal to the asymptote value, x not equal to 0. And the same for the y values. If I come from the left-hand side, from the negative infinity side, can you see that this graph comes from negative infinity? And it carries on to positive infinity. So the range is y element of all the real numbers. But again, the graph does not exist there at minus 4. So you must remember to exclude the asymptote that has to do with y. So y cannot be equal to minus 4. So if you can just remember, the asymptote that has an x in it, you must exclude from the domain. And the asymptote that has a y in it, you must exclude from the range. And I say again, the reason I love to ask that is because you forget to exclude. Okay. Let's draw another one. Draw y equals minus 1 over x plus 2. Give the intercept or intercepts with the axis, asymptotes, domain, and range. So now first thing is, again, shape. Now because that a is equal to minus 1, it's a minus, your graph will be in the second and fourth quadrants. The asymptotes, now what happened now? Because there's a plus 2, the graph moved up by 2 units. So your asymptote is now y equals plus 2. Y equals 2. My x asymptote remained the same. That vertical asymptote remained the same. So that's still x equal to 0. Because the whole graph moved up, it means this half will also move up and this half will also move up. So can you see again that I have an x-intercept? So I must calculate the x-intercept. And for x-intercept, I make y0 So I take the 2 to the left-hand side, or it doesn't matter which one you take to the other side. Make this minus to a fraction because it's easier to work with fractions if everything is fractions. Cross multiply, then you get minus 2x equals minus 1. Divide that minus 2 away. Minus 1 divided by minus 2 is a half. So now I can draw. You always start drawing with the asymptotes. So x equals 0 is that asymptote there. And y equals 2 is that asymptote there. It goes through 2 on the y-axis. There's my y-axis and my x-axis. The shape we said is in the second quadrant and in the fourth quadrant. And I have an x-intercept. I calculated it and it gives me a half. Okay, I've given the intercept, asymptotes, now the domain and range. So domain, we said from minus infinity to positive infinity. So the x is element of real numbers, but remember to exclude the asymptote. Range, y element, can you see it comes from minus infinity, it goes to positive infinity. So it's again y element of all the real numbers, but don't forget to exclude the asymptote. If you forget that, you are going to lose 2 marks. Okay. Okay, now we go to the exponential function. Y equals a to the x plus q. Now, how do you know it's an exponential function? Exponential function, the x is in the exponent. That's how I remember it. The x is in the exponent. Now I know it's an exponential function. Now again, this a tells me how the graph should look like. Now you have 2 mother graphs. The one is the increasing one, and this will be when a is bigger than 1. And the decreasing one will be when a is between 1 and 0. In other words, a fraction less than 1. So if I can give you numbers, for examples, this will be like y equals 2 to the x. And then this one will be like y equals a half to the x. Now for the mother graphs, the x-axis is also an asymptote. Graph is coming from minus infinity to positive infinity. It's increasing if a is bigger than 1. Can you see if you come from the left side and you hit the graph with your bicycle? You are going up, increasing. And if it's a fraction there, if you hit the graph, then you go down. So this graph is decreasing. This graph is decreasing. So the whole graph is increasing, the whole graph is decreasing. So the A gives you the shape. Now, if I add a Q there, if I add a Q, again, it means the graph moves up if it's a positive or down if it's a negative. And that Q will give me an asymptote again. Now, which asymptote will move? Can you see the horizontal one? There is only one asymptote for an exponential graph, eh? So that gives me the horizontal asymptote. And again, up if Q is positive, down if Q is negative. And then what does X and Y stand for? It's again any point, the coordinates of any point on the exponential graph. Okay. Now, can you see that for both of them, the domain, can you see the graph comes from negative infinity and it goes to positive infinity. So the domain is x element of real numbers. For that one as well, comes from negative infinity, goes to positive infinity. The range means y values. And you come with your bicycle from the bottom. Where's the first place that you can find the graph? It's just above the horizontal asymptote. Because remember what an asymptote means. The graph wants to go to this line y equals 0, because that asymptote is y equals 0. So the smallest value is 0, but 0 is excluded because 0 is actually where the asymptote is. So I cannot include the asymptote, so that's why I exclude the asymptote. And then it goes to positive infinity again. And the same for this one. The smallest value is, it wants to go to the asymptote, which is y equals to 0 again. But it doesn't hit that line ever. So it's just above the asymptote, which is 0, up to positive infinity again. Now, I want to explain something else. You must remember that 2 to the minus 1. What is 2 to the minus 1? 2 to the minus 1 is also equal to a half. Can you remember from exponential laws? Grade 8 and 9 and 10 exponential laws. 2 to the minus 1 is the same as half. So if you have a half to the x, it's this decreasing function. But 2, I can write a half, I can write as 2 to the minus 1 as well. And what happens if you have a power to a power? You multiply the exponents. That will become 2 to the minus x. So what I want to say is, if you see y equals a half to the x, Or if you see 2 to the minus x, you must understand it's the same equation. A half to the x or 2 to the minus x is the graph of this one, this decreasing one. So don't let that catch you. It's the same graph. Okay, now let's do an example. Draw y equals 4 to the x minus 4. Now the shape, because a is 4, it's bigger than 1, so it will be an increasing exponential graph. Exponential because the x is in the exponent. Can you see that minus 4 tells me that the graph moved down with 4 units, so the asymptote will be y equals negative 4. Now, if I start drawing, you will see y equals minus 4 is now my asymptote. And that graph that was there must now move down. So that means I can you see there, I can have an x-intercept and I can have a y-intercept. I can have an x-intercept and I can have a y-intercept. So before I move, I must first calculate the x and the y-intercepts. Okay, so again, for y-intercept, you make x equals to 0. So y equals 4 to the, make x 0, and 4 to the 0 you know is 1. 1 minus 4 is negative 3. So I know the y-intercept, this is the line y equals minus 4, because that's the asymptote. Now the y-intercept will be negative 3. To calculate x-intercept, you make y equal to 0. So now you have 0 equals 4 to the x minus 4. Take the 4 to the other side, then you have 4 to the x equals 4. Can you remember how to solve exponential equations? The bases must be the same, then the exponents will be the same. All the exponents will be the same, then the bases will be the same. Now I have the same bases, so therefore the exponents will be the same. So my x-intercept will be 1. So now I can draw my, let's draw a new one. So now I have my x-intercept and my y-intercept. So now I can draw my exponential equation, my exponential graph. Okay. So now the domain and the range. X element of, can you see it's simply from minus infinity to positive infinity. So x element of R, there is no asymptote with an x in it, so I don't have to worry about that. The range, where's the graph? If I come from the bottom, from the minus infinity side, where's the first time that I will hit that graph? Just above the asymptote. Just above the asymptote. So it will be y. Now either you can say element of round bracket minus 4 to infinity, or you can say, if you don't want to write it like that, you can say all the y values are bigger than minus 4. Doesn't matter which one you say, both is acceptable. Okay. Now I want to say some more about, okay, there's another one. So let's first draw that one. Y equals 3 to the minus x. Now remember what I said. y equals 3 to the minus x plus 1, 3 to the minus x is the same as a third to the x plus 1. Don't let I catch you with that. So my shape will be the decreasing one because there's a fraction less than 1. And because it moved 1 up, my asymptote will be y equals 1. So you always start drawing with the asymptote. So the asymptote is always a dotted line, y equals 1. Now it's the graph above the asymptote. So can you see all that you have to calculate is a y-intercept. You don't have to calculate an x-intercept. I will show you now if you don't see that. So let's calculate the y-intercept. For y-intercept, you make x0. So you have y equals 3 to the minus 0 plus 1. Now 3 to the 0, 3 to the minus 0 is just 1. Anything to the 0 is 1. Plus 1, that gives me a y-intercept of 2. Say I wanted to calculate an x-intercept. Let me just show you what's going to happen. For x-intercept, make y equal to 0. So now I make my y equal to 0. 3 to the minus x equal plus 1. If I take this one to the other side, 3 to the minus x equals 1. Okay, now I've minus 1, minus 1. Is it possible that a positive number to any power can give you a negative answer? Is that possible? I'm asking again, is it possible that a positive number to any power can give you a negative answer? No, that's not possible. So there is no solution for this equation, and therefore you know that there's no x-intercept. Okay, so if you didn't know and you wanted to calculate it, it's no problem. You would see that there's no solution and there's no x-intercept. Okay, so if I want to know the domain, again, I say x element of real numbers, or if you prefer to say x element of minus infinity to positive infinity, that's fine, as long as you put round brackets there. Range, smallest y value is just above the asymptote, so it's either 1 with a round bracket to infinity, or if you want to say y bigger than 1, it's also fine. They can ask you, is this an increasing or a decreasing function? And you will say this is a decreasing function. I forgot to say for the parabolas, so I'm just going back to my first parabolas. If I have a smiley parabola, a parabola is the only graph that you're going to do. Well, don't forget about the trigonometry graphs. Yes, the trigonometry graphs as well. But the parabola is the only one of the algebra graphs that is decreasing as well as increasing. If you come with your bicycle, you are going down up to the turning point. And then the graph is increasing again. So a parabola is the only one of these graphs that is decreasing up to the turning point and then increasing again. And the value that you want is always the x value of the turning point. So the x value of the turning point is where the increasing, decreasing changes. If you have a sad parabola, can you see now it's first increasing up to the x value of the turning point, and then it is decreasing again. And they often ask you that. Give the x values for which the graph is, and then they ask increasing or decreasing. And then you will always use the x value of the turning point. Okay, so we will do that tomorrow again, then you will see. Okay, I want to show you something else about the exponential graphs. If I say draw y equals minus 2 to the x, what does that mean? We started with that one and we said that was y equals 2 to the x. By the way, what is the y-intercept going to be? Remember, for y-intercept, make x equal to 0. 2 to the 0 is 1, and it's an increasing graph. Now, what does it mean when they say minus 2 to the x? Now, I want you to look at your screen and hold your arm, that your arm looks like an x-axis, and wiggle your thumb. Okay. Now, can you see my thumb is at the top, at the positive side of the x-axis? My arm is now the x-axis. Okay. My thumb is above the x-axis. What do I do if I reflect my hand in the x-axis? Look at your thumb. What happens to your thumb? Your thumb goes to the negative side. So if you have your thumb at the top and you reflect your hand in the x-axis, your thumb goes to the negative side. So if you see y equals plus 2 to the x and you see y equals minus 2 to the x, what happens? The y values, now the y values is like your thumb, because your thumb is now at the positive y values. That means your y values changed from positive to negative. And what does that mean? You have a reflection in the x-axis. So if I want to draw y equals minus 2 to the x, it's just the reflection of y equals plus 2 to the x in the x-axis. And what happens? It goes like that. My y values change sign. Now can you see that plus 1 now become a minus 1? And does it really work if I test it? What is minus 2 to the 0? 2 to the 0 is still 1. Minus times 1 is still a minus 1. Now can you see the increasing graph now changes to a decreasing graph? So what I want to tell you is that if you see a minus there for an exponential graph, the graph is below the asymptote. If there's a plus, the graph is above the asymptote.
I'm
Yes. if you see a minus for an exponential graph, the graph is below the asymptote. Okay, because they are reflections of each other in the x-axis. And then the same will apply if I say draw y equals a third to the x, and I ask you to draw minus a third to the x. Because a third to the x is that one that's decreasing. Asymptote is still the x-axis. Y value, a third to the 0 is 1. Now, if I ask you to draw minus a third to the x, take your asymptote again. Can you see? Your x-axis. The y's just become negative, so it means a reflection in the x-axis. So your graph will just go like that. Your y-intercept will be -1, and your graph is below the x-axis. So this below the asymptote, minus a third to the x, and this one is y equals positive a third to the x. So if you go back to all your graphs, all your exponential graphs, the first two that we drew was positive above the asymptote. Positive above the asymptote. If you change the sign to a negative, the graph lies below the asymptote. If you change to a minus, the graph is below the asymptote. And then can you see that for this green graph, okay, the domain stays the same, but the range we said was y bigger than the asymptote. And if you look at this one, the range is now y smaller than the asymptote, below. Okay, tomorrow we will carry on with grade 11 graphs. See you tomorrow, same time, same place. Keep well. Bye.
Bye.